This is example 3 in section 4.9. We want to determine the derivative of y with respect to x for this function. And basically what we're going to do is we're going to differentiate each side of the equation with two variables, x and y. So the first thing we're going to do is take a look at the procedure. We're going to try to collect the terms involving dy dx. We're going to factor out that dy dx and then solve. So here we go. I'm just going to write down the question one more time. So when we differentiate y with respect to x, we're going to differentiate each term. So when you differentiate x squared, you're going to get 2x, but then you're going to differentiate the variable x with respect to x, which means this ratio will cancel. Then we're going to look at this product. So we are going to use the product rule. So we're going to take x and we're going to differentiate y. So when we differentiate y, we get 1, but then we're differentiating the variable y with respect to x, plus y times differentiating x, we get 1, and we differentiate x with respect to x. Again, that will cancel. So that's your product rule. Then you differentiate the next term. Y squared would be 2y times the derivative of y with respect to x. And the derivative of 5 is just a constant, so that's 0. So you see that you have dy dx, and we're going to see that we have two of them, so we are going to try to combine and factor. So this is going to cancel, so you end up with 2x plus x dy dx plus y plus 2y dy dx equals 0. So in order to factor out common terms, we're going to put them on the same side. So we're going to leave them where they are. So x dy dx will stay. The 2y dy dx will stay on the left side. Negative 2x and the negative y will go on the opposite side. So you see you have a common factor. So dy dx is my common factor. So what am I left with if I divide by that? You're left with x plus 2y. Again, negative 2x subtract y will stay. To solve for dy dx, which is what I'm trying to do, I'm going to divide both sides by x plus 2y. And then this will cancel. So I'm left with negative 2x subtract y over x plus 2y. So you see that the slope of your tangent line is dependent on the x value and the y value here. So if I did give you a coordinate and asked you to find the slope of a tangent line, for any coordinate you'll get this.